My name is Mehmet Akif Tütüncü. I am coming from Netherlands. I work at IO as a senior software engineer and work at Rabobank as a consultant through IO. And today I'm going to try and answer this question. And this is the outline of my talk. I'm going to speed up the first parts a bit. I'll give a brief background and the motivation for this talk, go over the current state of JVM languages, namely Scala, Kotlin, and Java, and then talk about the way that developers work with these languages, like the ecosystem, the tooling, the practices they use, etc. And then give my opinions about what I think the mindset of such developers are. And hopefully to just give you an idea of what else is going on in the world that is not writing Scala. So let's begin with this. I started with Java, like many other people who work on JVM, and that was during when I was still in university. Then by some luck I actually ran into Scala and started working at Scala. I would even dare to say I fell in love with Scala. And then I also started doing Kotlin after a while, and I worked with all these three languages professionally on different platforms, different projects, different tech stacks. And in a way, I got to experience the evolution of these languages over time. So that's sort of the main motivation of why I'm here today and talking about this stuff. Because the interesting point here is my relationship with Scala, even though I have used it extensively and love it, is really on and off. I did some years of Scala, then switched to something else and stopped doing Scala for a while. Came back to Scala, then switched back to something else again, and used Scala for my hobby projects along the way. So it's really on and off. And I think that gives me some perspective to the outside world, and that's why I'm here today. So I'll start with the current state of things. As of today, Scala has 3.4.0 and 3.3.3 long-term support releases available, and 2.x series are still actively commonly used. It is a language we know and love. It is expressive, concise, functional, scalable, many more things that we can assign to it. I think it is the best of both object-oriented programming and functional programming world, and it goes beyond the JVM. It is also available for JS and Scala native with such projects. So that's Scala we all know. There is a strong competitor, in my opinion, these days to Scala, which is Kotlin. It also happens to be the language I currently work with. And there's 1.9.23 available, and Kotlin 2.0 is being worked on and coming soon, hopefully. It is also a powerful language. It has a ton of features. It also goes beyond JVM, just like Scala does. And I think it goes even further because this supports even more target platforms. And even though you can do functional programming with Kotlin, it has many features supporting that. This is mostly a better Java because this is by design. That's how the language actually started. And then there's Java. Well, it has improved a lot. I don't know if you are familiar with Java. If I didn't have the issues at the beginning, I wanted to actually ask the audience, like, what other languages are you using? Are there anyone who is not currently writing Scala? But we just passed that. Java has improved a lot. In fact, when I was preparing these slides, there was Java 21, But then, just 2 days ago, they released Java 22, and I had to go and update the slides. 21 is the long-term support release, but the older versions, especially other long-term support versions, are really common to use. And it is getting better and better. They added a ton of new features in the recent years and the versions. They now have pattern matching, they have records, virtual threads, structured concurrency, string templates, which is really great to see there. Then garbage collection improvements, API improvements, many things. And even though that's the situation, even though there is some native support, Java is still about JVM. So, to paint a picture and not only talk, which would probably be boring, I wanted to also give you an example and show you some code. I prepared such an example, small program for listing, having some people and doing some operations on them. This is the example in Scala. I'm going to have the same examples in Kotlin and Java as well. And I paid attention to this so that the code you see is actually will be runnable. Copy this, paste it into your editor, and should be runnable. And I'm going to turn on the laser pointer here to point at certain things. So this is probably familiar. There's a case class for a person with name and hobbies. Hobbies are optional. People may not have hobbies. And that's how we denote that in Scala using option type. And there is a list of people here with some initial data. I typed this as list any to demonstrate certain things, so that this is not inferred to be list of person. And what I'm doing here is I'm calling a collect on this people list, and I'm doing a pattern match, which is something really strong in Scala. And here I am handling that this any object is a person, that it has hobbies, I'm ignoring the name, and the hobbies being empty or non-existent is also handled here, and then I am capturing that entire object as the type of person. And then I am printing that that person has no hobbies. And because P is person, I am able to access directly to the name. And you may also have noticed that I'm using Scala 3 here with no braces at all, which makes for a nice slide. Now, let's see the same example in Kotlin. There isn't really much of a difference. The syntax of Kotlin from a high level also looks similar to Scala in many cases, but I'll point out to the differences. So there is data class instead of case class in Kotlin. The optionality of the hobbies is denoted by this nullable type. I will talk a bit more about this later. And then the application is the same. There is a list of any with the same values. I did, however, add a custom filter by function here, which is an extension function, which is also an inline function, which is also reifying the generic type parameter that it has, so that it can retain the type information and it's not lost in the type erasure. I did this to have the nicer API here, and to also demonstrate that the standard library has a slightly different set of operators allowing me to do this. But I am specifying that I'm filtering by the instances of person, and this already is giving me access to the input variable as a person, which is also referred to by it being the implicit variable name for that. And because this is nullable, I am able to safely access this value and also then use this so-called Elvis operator to have a default value. So that's really the same thing. And a few more words about how null works in Kotlin is they handled this with nullable things being a different type. So a set of string question mark is a different type than set of string. And set of string, the non-nullable version, is a subtype of set of string question mark. So that's, I think, a really elegant way of solving it, and it makes for a really nice user experience with this null safe access operator and the Elvis operator. So that's enough about Kotlin. Now I'm going to move to Java, but do not be scared. So this is probably what you expected from Java, right? Well, you're wrong. That's not really Java anymore. This is Java today. And this is also really short and almost the same thing if you look closely. However, there are still some issues which I'm going to now point out. There is a new type called record in Java, and this is Java's way of having immutable data models, which is really nice to see, but there isn't really a way to enforce certain things being null or not. I just added this nullable annotation as a sort of hint, because when you have this in your IDE and in your tooling, you get extra benefits. Then there's list.off collection builder. There are also set of, map of, and similar builders. And one interesting thing about this, besides that it lets you create a list easily with the given elements, is that it gives you an immutable list, even though that has the same interface. It's still a list. It is actually an immutable list, but it is an immutable list at the runtime. It's still the list interface. It still has the add method, but go ahead and try adding an item after creating this people. You will get an unsupported operation exception at runtime, which is not nice. But then to do collection operations, there's Stream API, and with the filter here, what I'm doing is a pattern matching. I'm checking the type of the object P with instance of, but in that type check, I'm also doing a pattern match because this is a record. I'm able to do this, and I'm able to deconstruct this into its components, and I'm even able to give the variables var so that I don't have to define the type, and it can be inferred. I can even do underscore now with Java 21 to skip naming that variable. I can add guard clauses just like how I had in other languages. And then in the for each, when I'm printing, what I'm doing is string interpolation. Java now also has this. It is a bit similar to how you do it in Scala, in fact, because this str thing is what's called a template processor. This is the standard template processor that does string interpolation, and it is imported automatically so that you can use it without any explicit imports. There are other template processors, and you can even write your own. And this is really what you can do with modern-day Java. And before I move on, there's one thing I also wanted to point out. Have you noticed the main method? Has anyone ever seen a main method like this? Right? Good. Because this isn't really your usual public static void main method that you would shove in a public class in your file. This is a top-level, instance-level main method, which Java now supports. As I mentioned, this is runnable code. Paste this in your editor, and you should be able to run it with Java 21. So, enough about that. What's the verdict now? I would say writing Java isn't really what it used to be some years ago. It's definitely improving and catching up and like gathering many popular features from other languages. And in my opinion, one thing that's still missing is the extension functions. Kotlin is definitely a better Java. It can be quite fun to work with. You can even do some functional programming with it, as I mentioned. And my personal favorite is the null handling features. And of course, Scala does some things better than the others. And it has done these things before they were cool, basically. It had all these features way before than the others. So now let's move on to the way of working with Java. Like, what do developers do? Well, they do annotations. And this is actually a code snippet from the project I work on. I copied the code and just changed it so that it is Java. And so that's the situation. But it's not only the fault of Java. This is a Spring Boot code. That's why you'll see a lot of annotations here. And we even have these custom annotations called meta annotations that contain other annotations so that they would fit on a slide. But that's also slightly there for a joke. Anyways, because I'm talking about my personal experiences today, and I am mostly doing backend work and web development, I wanted to talk more about that and what backend developers, what web developers do with Java is that they use frameworks. And these are some of the common ones, with Spring framework being the most common one. And they all have annotations. They work with annotations, and for really basic stuff, you probably wouldn't be able to tell a piece of code whether it is written for Spring or Quarkus or Micronaut or not. But a sort of different approach Java developers might take is to do reactive programming, which some, if not all, of these frameworks already support. And for Spring Boot, Spring Framework, for example, there's Spring Web Flux module, and that allows you to do reactive programming with Project Reactor behind the scenes. But yeah, that's what Java developers usually do on the back end. They use these frameworks. Then there's Kotlin, which is, when you do Spring Boot, is really the same thing. And this is the actual example I copied, with nothing changed. But then that's not the only thing that Kotlin developers can do. There are alternatives. There's Ktor, which is developed by JetBrains, which lets you do like idiomatic Kotlin to have server and client applications. It's, if I remember correctly, it also supports coroutines and stuff, which is really nice. It also sort of has its own ecosystem and supporting libraries, and I think they call them plugins in the Ktor. So you can use that. There's also HTTP4K, which should sound familiar if you are familiar with HTTP4S for Scala. It takes the idea that the handler for a web application or a server is basically a function from a request to some sort of effectful response type. And that effect would be different in Kotlin. And then the sorry, perhaps the biggest selling point of Kotlin would be coroutines. They allow you to do asynchronous programming with this direct async await kind of style. This is the example I took from their documentation. Any guesses what would be printed when you run this code? Hello world 1, world 2, and then done. Perfect. That would be the outcome, because coroutines are non-blocking suspending functions. When you run the code, it would come here. Then when it wants to delay, it would suspend, then continue. It would suspend, then continue. Do this. When the delay is done, do this, then do this, and then it would print. So that's very simply how coroutines work. And then there is this amazing set of libraries called Arrow, which lets you do really cool stuff, functional programming. It gives you some functional programming constructs and types. And this either control block makes it really look like this for comprehension for the eithers on Scala, right? This is really cool to see. Either is what you expect. It's really similar to the either in Scala. This comes from the Arrow library. So Kotlin users are luckier in this sense compared to Java ones. Then, I think this is the slide I'm going to spend most of my time, if I have any more. And I wanted to just highlight some of the topics and sort of align them to each end, to opposite ends. And I also wanted to align the languages along these lines a bit. To the left side, I put Scala. To the right side, I put Java. And Kotlin is, well, in the middle, because it has stuff that's on the right side and on the left side. Anyways, so for compile time versus runtime, as Scala developers, we tend to like to do things on compile time. We want our compiler to work for us. In many cases, that's why we have macros. We have like inline definitions. We have compile time constraints. We have constraints on the types, etc. But on the Java side, things are mostly done and depended on at the runtime, which is unfortunate because it's not as safe as compile time. You have an issue, compiler just shouts at you, and you can't even do anything else. But you have an issue writing Java, good luck. You may very well find it on production when everything blows up. So that's unfortunate. Then there's being explicit, open, and like discoverable versus being hidden and auto-configured. And I'd like to call this also dark magic, because that's sort of what it feels like. Have you ever tried creating a web server application, like backend application from scratch in different languages at the same time? It's when you notice this first. You want to create a Spring Boot application, right? Go to start.spring.io, Spring Initializer, create an empty Spring Boot project, download it, and it would just start running. And it configures, auto-configures, because that's what they call it, a ton of stuff for you. There's an application server running, dispatcher servlet, configurations, property bindings, and all that stuff. And it just works. And you want to add a new functionality, you just add another dependency. And the fact that there is that jar in your class path makes it auto-configure even more stuff. And good luck trying to figure out what it actually auto-configures and how it does that, and how can you work with this. Whereas on the Scala and perhaps on the more functional programming side, you do things explicitly and like consciously, You want an application server, you make a conscious choice about that. You pick something and configure that yourself. You want to add a new functionality, perhaps connect to the cache. You add your dependency, but you also set up how to work with that yourself. So, in my opinion, even though the other sounds really tempting, working with it, it's better in Scala. So, there's also the type safety versus the reflection. This also comes from the power of the type system in the languages. Scala has undeniably a better type system. Again, these are just my opinions, but I'm happy to talk afterwards. And that gives you really expressive power and the safety when you are working with your types. And in Java, most of the things are done via reflection, which is, again, also related with compile time versus runtime thing, but that's the situation. And immutable versus mutable, again, this is something related to the mindset of the developers. Scala made it so that things were immutable by default, and that really changes the way you work and changes the way you think. Whereas it is really common to create an object, then mutate it to set certain fields, then pass it along. That other places makes further modifications to that object. It's really common practice in Java, which isn't nice or safe in some cases. And the language pushing you to the immutable direction is usually the better way to do. And then there's the functions and compositions versus design patterns things. This isn't really like this is good or bad comparison, but it is out there because Scala focuses more on the functional programming. It lets you build your programs out of smaller functions and compositions among them. And on the Java side of things, well, when you want to achieve something, there's usually these two words come up: design pattern, and while that's okay, I believe, and I think that was the case for most of the things. Most of the stuff that you do with design patterns, you really don't need when you are doing functional programming. You have the ability to work with functions, pass them around, assign them to variables as values and stuff, and you can just get away with doing things with functions, and you don't really do design patterns. So, do I miss writing Scala? Yes, I do, but others aren't that bad. They are improving, and that's what I wanted to show you today. Thank you very much.